Okay, today we're just going to review over proofs. So first we're going to go over the reasons why the sides of triangles are congruent. So first it's going to go over sides. Okay, the first one is the easiest one, is because it's given to you. So here we're going to have examples like this, like given information of what we need to prove in a diagram. And based on this, we're supposed to identify congruent sides and congruent angles. Okay, the first one is this one, like given that side PQ, so side PQ is congruent to side ST. Given that, so I want you to get your red pen and put those annotations. Side PQ congruent to ST. How do we know? Because it was in the given information. So over here on reason, the reason is because it is given to us. Okay, then not only that, we continue reading. It says that PQR, so it says that side QR is congruent to side RT. So side QR, this one right here, is congruent to side RT, this one right here. How did we know that? Because it was given. So that is one of the easiest reasons to identify congruent sides, because it's given to us. The second one, it was definition of a midpoint. And remember, the definition of midpoint is a point that is in the middle. So it's a point that located in the middle. So for example, here it says R is the midpoint of line segment PS. So R, point R, this one right here that is located right here, is a midpoint, so it's located in the middle. It's located in the middle of P to S. So from P all the way to S. So it's in the middle of that. So that's make what does that mean? That here, this section right here is going to be congruent, PR is going to be congruent to RS. So these two sides are congruent because R is in the middle. Okay, so that means that side PR is congruent to side RS. And the reason is because we use the definition of a midpoint. That's how we know, because they told us in the given information that R is a midpoint. In basing our definition of midpoint, we know that these two sections are going to be congruent to each other. So that's one example. The last reason that sides are congruent to each other is something called reflexive property. And what that means, it's a side that is congruent to itself. So how do we know that it's reflected in a picture? Because we're going to see that the two triangles are sharing a wall, remember? Like they're sharing a wall, they're sharing a side. So it doesn't mean, like in each diagram, guys, they're always going to give you two triangles. So for example, let's identify one of the triangles right here. We have this triangle right here. That's one of the triangles. And then we have this triangle right over here. You have those two triangles, and you see how they're sharing this side right here. That's called reflexive property, and it's congruent to itself. So the side that's being shared by both triangles is side AB. And since it's being shared by two triangles, we know that side AB is congruent to itself. So side AB is congruent to side AB. What is this called? The reason will go here. Reflexive property. That's the reason that we know that those two sides are congruent. So remember, if you're still not understanding like why is it congruent, it's because imagine that we were to like cut these two triangles. We were to cut them. I'm gonna draw this one separately, this triangle over here separately. I'm gonna draw triangle ACB over here, is the one in yellow, and I'm gonna draw this one over here, the one in pink over here. ABD. See, this is the yellow triangle right here that is over there in the picture. And then this triangle represents that yellow. So you see how they have a side that's named the same? You see? So that means that this side AB is congruent to the same side over here AB because they have the same side. Does that make sense? So that's how we identify congruent sides. Now we're going to move on to congruent angles. So the first one, the first reason that angles are congruent is because it's given to us. That information is given to us on the given information. So you see how over here they're telling us right here that angle JMN is congruent to angle LNM. So that's how we know. So they're telling us that this angle right here, we follow the letters JMN right here. This angle is always the one in the middle, like we see how you fold it. That angle is congruent to this angle right here, which is LNM. This one right here. So how did we know that those two angles were congruent? Because it was given to us on the given information. Okay, and then we move on to the second reason, that is we use the definition of an angle bisector. Okay, and the definition of an angle bisector is a line or a ray, whichever you want to say, a line or ray that cuts an angle in half. Okay, so this angle that cuts in half. So this segment right here, this little statement is telling us, oh, something's being cut in half. And here it's telling you that, oh, side BD. So B to D. So this line right here is bisecting angle ABD. Bisecting angle ABD. ABC in half. So let me zoom in. Let's pretend let's draw that bigger, okay? So we have this section A, B, and then C right here. So I'm going to put A, B, and C. And this is the angle that they're talking about. This angle can be 50, can be 60, whatever. But this line right here that I'm about to draw, B to D right here, that is cutting this angle in half. So let's say that the angle was 60. Let's cut an angle in half. That means 60 divided by 2 means that this section will be 30. This angle right here will be 30. And then this angle will be 30. So this means that this is congruent to this. Whatever the measurements are, they're going to be equal because this red line is cutting that angle in half. So that means that angle A, B, and then D, that angle, is going to be congruent to whatever this angle over here is. And it's going to be angle CBD. Whatever the measurements are, we know they're congruent because this red line is cutting that angle in half. And the reason that we know that these two are going to be congruent is because they're telling us that this is the definition of an angle bisector. Okay, so technically this is trying to tell you that this section and this angle, those two angles are congruent to each other because that line BD is cutting angle ABC in half. Okay, and then the other one that we need to go over is vertical angles. So whenever they give you a diagram, you always need to step back and look for these type of angles. Angles that are crossed, those are called vertical angles. And if you're able to identify these angles on a picture, you need to say like, oh, those are vertical angles, therefore they are congruent. So we can say that angle, what? Angle JKL, that angle right there, JKL is vertical to angle MKN. If they're vertical angles, we know that they are congruent. And how did we know? Because we identify them as vertical angles. So we just went over the reasons that sides and angles are congruent. Now we're